Welcome to another episode and video on my ESP32 right here. An Internet of Things device currently connected to an LED, semi-segment display, event microphone, so it doesn't record voice, just like this should be. Servo motor, keypad, LCD, and somewhat hidden an LDR, light dependent resistor. I am not talking about the buzzer because it's currently disconnected. Probes are first, oops, that's a wire. Probes to the signal, outgoing signal from the microphone. Pulse modulation for the motor, 3.3 volts towards the motor and LDR, and measuring the signal to one of the GPIOs here, which brings me to the current state. So I haven't loaded the program yet. And IoT is, in my version at least, volatile memory. That means that if I remove the power which it gets through data cable and power cable, once I remove it, it goes off and everything goes off. So that's one thing. Once loaded, it turns out that the motor doesn't always work. This does work depending on the wires, which I should improve, but as yet not done. Keypad, some issues as well. If you have seen my starting videos, then you've seen that that not always works, or more appropriately almost never works. LCD does work. LDR, light dependent resistor, does work. LED does work. So what am I doing now? Well, the buzzer should, according to the algorithm that I wrote in C, AVR C, give an SOS originally. You know, SOS, 3 long, 3 short, 3 long. No, 3 short, 3 long, 3 short. Yeah, that's SOS. Anyway, that doesn't work. It beeps now and then, but not according to the algorithm. Then I had it connected here, by the way, to 0. And as soon as I disconnected it, a sinusoid at 3.3 volts disappeared. So that's a bit weird for a passive device. Well, passive, it's active once activated, but otherwise it doesn't do anything. So I decided to put it here to another IoT GPIO, which gives hardly anything either. So let's upload and hope that everything works. And so far so good. And you see the LED, and that's something that I, well, doubt as well. It only does that when I'm uploading, and it should do something when I snap my fingers. That's something weird as well. Anyway, now it starts working. And I have to set the oscilloscope to pulse modulation, and then things actually give the nice signal, which does not mean that it actually works. Anyway, let's go see everything else on screen. So, just observing things happening. Pulse modulation, voltage 3.3 volts, very nice. This is the signal for the yellow wire, which now does not anything which is justified by the algorithm, but right down here it should do something. So when does it do something? When the buzzer goes. No, when the buzzer should go on the screen as well. Here it should do something. Nothing happens. Microphone. Yeah, still a big riddle. Massive riddle actually. Because okay, stop auto scroll. Microphone and oops. Well, that should be repeated. No, regardless of this part of the algorithm, this should just be repeated. I can of course change this algorithm by saying, alright, I'm going to not do it each and every time, by that I introduce, and let me introduce that at the start, otherwise it's reintroduced each time. And where shall I introduce it? Here is a good time. So with the microphone, I introduce integer mic count and I declare it 0. Is that a nice thing to do? Yeah, that's a nice thing to do. So then I say while, not true, but while mic count smaller than 10, and then here of course mic count plus plus, assuming that will work. So that means that mic count is increased by 1. So it will happen only 10 times that it goes by, and in those 10 times something should happen. Let's do it, and it's okay. Now you see also here that things are happening which coincide with this LED and the flashing. So going back here, yeah, that was alright. So, oh wait, how is the mic count? I should print how the mic count is. Oh, right. Auto scroll is nice. Even that doesn't work. Oh really? Mic count. So let's say here serial print line make count is, oh, I can't do that. In NCC I can, in here I cannot. So now, and that is something odd in my opinion. While in standard C, NCC, you can on one, in one line say, print something and then new line. You can't do that here. So now I have to put another new line, and this would work. Upload. At least now I can see whatever is happening, and once again the strange signal here. There we go. LCD works. Motor still hasn't done anything. Now I'm very curious what happens. Time for the motor. No, microphone. Time for the microphone. Oh, see, nothing of it happens. Okay, I'm doing something else. I will rewrite the whole while, because this is nothing. Alright, rewritten the while loop into a for loop. Make count starts at 0. Oh wait, I have now actually introduced it double. Doesn't really matter. Let's remove this. Just declaration. Now I initialize it, and until as long as make count is smaller than 10, do it and increase the value. So it will be executed for 10 times. There you go. LCD working nicely. No disappointment there, at least. Even if I don't snap a finger, it still should print no 7. But will it? It should do 7 times. No, 10 times of course. No, it doesn't do anything. No kidding. Okay. Another attempt. Command. So now I have no reading from digital 7. I only have now 0 print, 5 pieces, which should be written on screen 10 times. No, 4 lines of course. 1, 2, 3, 4. because these two will be printed on the same line. Go. This is making me very curious. Why is, like I showed last time and the time before that, why is the NCC procedure working and not this one? And by the way, I have to rewrite the other one, the NCC version, because that is still a while. And it's still true or false. Oh, see, this is happening. Microphone. Yep. 0 to 9. 10 times. So, there is something wrong with the ifs. But what? Very curious indeed. I have to search into it, look for it, because this has an explanation, of course, but which one? Right, I searched more documentation and I changed the algorithm even more and came to a conclusion, well, to some findings. First, this now works. Why does it work? Well, one of the reasons I think is that AVR C is even more different from standard C than I thought. I had here exclamation mark, which in standard C means not. I also had here this outer bracket right here. So I changed that into equal to 1, and this one no exclamation mark but equal to 0, which in my opinion means exactly the same, but anyway, this suddenly starts to work. Now if I look at this signal, and this is signal incoming to 7 because it's out of here and into pin 7, which I expected it to be, which is correct because now it says 7 is 1. But why is 7 1? Why is it high all the time? That is something that I don't get. And looking at the microphone output, it is analog versus digital, and on that side this is digital out. At least I assume it is digital. The O, it is an O and not a 0. Apart from that, what happens if I do this and count? So let's run it, and when I see it count I have to snap my fingers in the hope that that works. And unfortunately I do not see a signal change. So that is not helping. That is not working. Am I doing everything correctly? Oops. I can't say for sure. I do hope so, of course. What if I force it and I remove the wire? Will the LED go on? So I will have to remove the wire somewhere, I think. Question is, of course, where do I do it? Well, let me just do it right here. So now the wire is off. What will be the difference? Will the LED now burn or not? No, it won't, because it will be 0. If 7 is 0, do nothing. But right now I already said if 7 is 1, which it is, then it should burn. So this is a reason that is not correct. I better put it in again. Nicely and safely. I need some tool to get that right. Not the ideal tool now. Non-solid wires are difficult to deal with, but most are not solid. So, alright. And on again. So, how to deal with it? How do I get digital 8? Right, because if this is 7, then this is 8, no doubt about it. Something very different. I have decided to use the LCD more, and I made a little bit of a mistake, which I will correct soon. So this is now the usual string here, and after that I will make small announcements on the LCD. However, the way it is now, it just fills the LCD and doesn't clean up. And it seems to lose even characters. So now it goes off the LCD. What I want is to actually have them on one line. So now I will upload the set cursor 00, which I could do, of course, by changing a row, and then they will be, if it is alright, each time at the same space, overwriting the other, I hope, because that is to be expected. If it doesn't, we'll see then. Alright, LCD start, servo start, nice. Although it is, oh, there's something else. Keypad start, buzzer start, you're right. Nice, microphone start. Not flinch yet. And it goes new. Well, that is for a little nice change, but back to the buzzer for now. Yeah, 8. Since the port 7 is correct, it reads it. This isn't. So, well, 8 doesn't work for some reason, but I'll let it go for now. Buzzer, yes, buzzer. Of course, SOS is not long, long, short, short, long, long. It is short, 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 long, 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 short, short, short. So if I want to do that, and of course the other one is this would be OSO. And apart from that, no problem in using OSO, but let's do this. Oh, digital write, yeah. What to do? Pin 23, because I moved the yellow cable to, or the yellow wire to pin 23. And according to the information, that is entirely correct. It can be used despite all annotations for input and output. So, high for 1 second, low for 4. Actually, is this correct? Beep, beep, beep. It should be short low. Short means 500. So let's test this again. See if the scope, the purple line on the scope, which means this one, yeah, I should see if this is going to set better. Yeah, it should. It should show it better. Let me test again. No. Alright, wait. It showed for a moment an improvement in color, like here. So why doesn't it keep it? Anyway, this is the purple line. This should go on, off, on. And not stay on for all time. And that's a bit weird. Anyway, let's try. No buzzer sound, just signal. And that will be about the last thing for this episode. Will it be or won't it be? And since the oscilloscope is set to 1 millisecond per time interval, it should be quite a signal. but I already missed it because it's on the microphone now, which means that it didn't work at all. Okay, that's it for now. And that's it for now. So at least the microphone thing does work with with while changing to 4. Wiring adjusted, or tested anyway, not adjusted. More things on the server, on the LCD server that doesn't work, and something with the microphone and buzzer, whatever. Thanks for watching. If you like this video, please subscribe to my channel and give the video a thumbs up. Leave a comment or suggestion, very much appreciated. You can also follow me via Instagram and Twitter. And please show your support by making a donation via either PayPal or Wired. And you can also become a patron to be mentioned as a supporter if you would like that. Your name will be mentioned on my website, and depending on the pledge you make, also with my videos. This is obviously going to be continued. Have a nice day, and bye bye.